Welcome, everybody. We're going to talk today about taking the fear out of fractions with right start fractions. This is part 2 of a series of 3. I'm Kathleen Cotter-Lawler, and we are going to again talk today about fractions. We've got the Peanuts characters here with the little guy saying, now we cut an apple in half and we have 2 halves, don't we? Now, that's fractions. You're trying to teach me fractions. You know I'll never understand fractions. This is how a lot of us feel about fractions. We recommend using a linear fraction chart. And part 1 of this series talks about the fraction chart and explores fractions and what does fractions mean. So if you haven't seen that one, or you don't feel you have a real good handle on what fractions are and how they work and what it means, you may want to go look at the part 1 of the series first. So again, we're going to be using a linear fraction chart to explore and work with our fractions. And in this part 2, we're going to talk about simplifying, addition, and multiplication of fractions. So with this chart, we want to allow the student or the child to explore the whole picture and the relationships within the whole using a linear perspective. Okay, so let's first talk about fractions greater than 1, because a lot of people think that fractions is just part of a whole. Well, 3 halves is a whole and then some more. So fractions is more than just part of a whole. So let's look at fractions greater than 1. Here I have my fraction chart. So again, we've got 3 1/3 equal a whole, 4 1/4 equal a whole, 5 fifths, 6 sixths, 7 sevenths, 8 eighths equal a whole. Well, what happens if I put on another eighth? Well, then I have 9 eighths, which would be the same thing as 1 1/8. I mean, it's almost anticlimactic when you look at it this way. So let's go from mixed to improper fractions. So each row here of connected rectangles represents 1. So for example, these coral colored ones or pink colored ones, these are fourths. So here I actually have 4 fourths, which would be 1, another set of 4 fourths, this would be 2, and this would be 3 fourths. So this one here is thirds, and this one is fifths. Okay, what we're going to do here is we're going to write each quantity as a mixed number, and we're going to write it as an improper fraction. So let's do the first one as a mixed number. Like we kind of talked about already, that's going to be 2 3 fourths. Pretty easy. Now let's write it as an improper fraction. So how many fourths do I have altogether? Or how many little pink squares do I have? Well, there actually is going to be 11 of those. So there's 11 fourths. Now, what's the fast way to figure out that it's 11 fourths? I can look at this here and say, well, this is 2 fours. So 2 times 4 is 8. And then I've got, back up real quick here. Here's where the 2 and the 4 is coming from. So I have 2 fours. I have 2 fours. And then I have 3 more, plus 3. 2 times 4 is 8. Plus that 3 is 11. This is how we can quickly come up with the improper fraction, 11 fourths. Now, I'm explaining it to you as we go along. We want the child to discover this. Now, obviously, we're not just going to stand around and hope that they possibly discover it. We're going to guide them to that discovery using these kinds of examples. So let's do the next one here. How many, write this as a mixed number, the blue ones. I would have 4 1/3. How many 1/3s do I have altogether? Well, some of you might be counting, but some of you are going, oh, wait, there's that multiplication thing happening. I can say that I have 13 thirds. So I've got 4 3s. 4 times 3 is 12, plus 1 more is 13. This is why the algorithm that you and I know how to do works. This is why it works. That equals my 13. Let's do the next one here. What do I have? I have 3 and 3/5. So how many fifths do I have altogether? I have 18/5. Because again, I have 3 5s, 3 groups of 5 here, 3 groups of 5, and 3 more. Remember, we want to help the child discover the algorithm. You don't get to just announce, here it is. Let them discover it so that they have the ownership and the excitement and the joy of that discovery. Let's do the reverse. Let's go from improper to mixed fractions. So here I've got, wow, a lot of fifths. And what we're going to do is we're going to write each quantity as an improper fraction, then circle the holes and write it again as a mixed number. So this first one here, there's a lot of fifths, and I know some of you are trying to count them right now. Let me help you out here. We actually have 11 fifths. So we want to circle the holes. So how many fifths do I need to make a hole? Well, I would need 5 of them. And look, I can get 2 groups of 5 here. So now I have 2 and what's left over? 1/5. Oh, that was kind of cool. Let's do the next one here. Write it as an improper. How many do I have? There's 5, 5 1/3 equal. Now let's put them in circle the holes. So how many thirds equal a whole? That'd be 3 of them. And I can't make another group. So what do I end up with? 1 whole, 1 and 2/3. This is how we go from improper to mixed. Again, remember to let the child to discover the algorithm. Again, you don't get to tell them, you guide them so that they make that discovery. All right, let's simplify fractions, because that's one of those things that kind of make people melt a little bit. So let's look at simplifying fractions. Again, we're going to come back to our linear chart. And here I've highlighted 5/10. What's another way of saying 5/10? It'd be the same thing as 1/2. Oh, that's all simplifying fractions is? Yes. Let's do another one here. I have 4/8. What's another way of saying 4/8? It'd be the same thing as 1/2. 3/6, 1/2. 2/4, 1/2. So they're all the same. That's all simplifying fractions is. It's just finding another name for that same amount. Now, you can also simplify fractions using a multiplication chart. So here, this is just your ordinary multiplication chart. I've got 7 times 5. I've got 9 times 7. It's just your multiplication chart. But on here, I can simplify in fractions. So I can say 5/10. Now, when we do this, when we make this into a fraction, they need to be in the same column, but they don't have to touch. So here I have 5/10. I can simplify it by taking it to the left and say it's the same thing as 1/2. Just like we saw on the chart. 4/8 is the same thing as 1/2. 3/6, 2/4. They're all the same as 1/2. So let's try to simplify now. Let's do 21/28. Again, I need to find the two numbers, the numerator and the denominator, in the same column. They need to be the same column up and down. But they do not need to touch. So do you see 21/28? Look in the sevens column right there, 21/28. And I take it to the left and I can simplify it down to 3/4. That's awesome. Let's do another one here, 45/72. Remember, they don't need to touch. They just need to be in the same column. 45/72. You see it there in the nines column? 45/72 simplifies to 5/8. Okay, so why does this work? Well, let me work through this with you. What are we doing? Remember I said that the two fractions need to be in the same column. So here we have them in the nines column. What's 45 divided by 9? It's 5. And 72 divided by 9 is 8. That's why it works, because you're dividing by the column that you're in. Let's do 12/16. Now, I happen to find it over here. 12/16 is 6/8, but look, here's 6/8 again. I can simplify to 3/4. So I can zigzag my way up if I need to. Now, I could have found the 12/16 here in the 4 column, but I didn't. It worked out. Isn't that awesome? Again, this explains why. Let's do this a little bit more traditionally. Let's look at simplifying fractions using pieces here. So here I've got 16 rectangles. 12 of them are colored dark. So I've got 12/16. Well, is there a way that I could group these and make it simpler? Now, I could try to group it in 2s. Well, that would probably work. Let 3s, I can't do 3s because I'm going to end up with 1 left over here. So let's try 4s just to see if we can do it. So let's try 4s. Now, I'm going to write the number 4, and I'm just reminding that to myself that I'm putting it in groups of 4. So here's 4s. Hey, that worked. I don't have any leftovers. So my answer is going to be 3/4. Now, I could have done 2s like we did before on the fraction chart with the 12/16, but I know 4s can work because I can see it over here and I tried it out, and yes, it does work. So 12/16 is the same thing as 3/4. All right, let's look at adding fractions. Back to our chart. What's 2/5 plus 1/5? 2/5 plus 1/5 is, well, obviously 3/5. I mean, that was really not even exciting. Notice how when you do it with the chart, there's no rules, you just see it. I've got 2/5, and 1 more 5th is obviously 3/5. Now, I didn't tell the child that you leave the 5s as is and you add these. I didn't say that. I just explored it and worked with it so I could see my numbers, 3/5. Let's do another one. 5/9 plus 2/9. Here's 5 1/9, 5/9, and 2 more 9s is 7/9. Huh, that was so easy. All right, oh dear, this is going to be more exciting. 1/4 plus 1/8, 1/4 plus 1/8. Okay, so what we're going to have to do here is we're going to have to see if we can find another way of saying 1/4. So I'm going to move this 1/8 over. And another way of saying 1/4, I can actually move it down. It's going to be the same thing as 2/8. 1/4 is the same thing as 2/8. Oh, well, now I can see the answer is 3/8. So again, we found the common denominator very logically. And again, once you do this, you start to realize the process, excuse me, the process of the procedure of the algorithm. Let's do another one real quick. 1/2 plus 1/3. Excuse me. Okay, so let's look at this. 1/2 plus 1/3. 1/2 plus 1/3. All right, this one's going to be a little bit trickier. Let's start out by taking my 1/2. If I move it to fourths, is that going to help me? No. How about 6? Yeah, this is going to help me. All right, so I'm going to remember this. Another way of saying 1/2 is 3/6. So let's go look at our 1/3. Another way of saying it is 2/6. Okay, this is going to work. 2/6. Let's take that 1/2. The other way of saying that was 3/6. And now I can see my answer is 5/6. All right, so let's look at how multiplying fractions work. Now that we kind of feeling pretty comfortable with addition, let's look at multiplying. Well, first of all, let's do it on the chart again. What's 1/2 of 1/2? So here's half. So what's half of it? It'd be 1/4. That's all multiplying is? Yeah. Let's do another one here. What's 1/3 of 1/2? Here's 1/2. What's 1/3 of it? I'm going to break it into 3 equal pieces. That would be 1/6. You just multiplied fractions. Nobody cried. That was super easy. All right, so let's look at multiplying fractions. First of all, most people think that multiplication is fast adding, but it's not exclusively fast adding or repeated adding. Because if I've got 4 times 4, it's actually 4 plus 4 plus 4 plus 4. Well, yeah, but when I do that with fractions, 1/2 times 1/2 is not 1/2 plus something. So it's not exclusively repeated addition. Area is actually a better model of this. So let's do our 4 times 4 using an area model. I've got 4 taken 4 times, and I can see my answer is 16. Same concept, it's just a different way of looking at it using area. So let's use area with fractions. 1/2 times 1/2. So I've got, what I'm asking again is, what is 1/2 of 1/2? Now we know from the chart, it's the same thing as 1/4. So we know what our answer is, but let's try to apply it using the area model. So here I've got my box. I'm going to cut it in half, and I'm going to crosshatch it. And then I'm going to take the other half, because I want to know what 1/2 of 1/2 is, and cut it in half horizontally and shade it. So what do I have? What do I have that's crosshatched and shaded? It's 1/4. My answer is 1/4. Let's do a harder one. Let's do 2/3 times 3/4. So again, I'm asking, what is 3/4 of 2/3? So we'll start out with the 3/4. I'm going to break it into 4 equal pieces and crosshatch 3 of them. So here's 3/4. Now I want to know of 2/3. So I'm going to go horizontal, break it into 3 equal pieces, and I'm going to color the 2 out of the 3. So what do I have that's crosshatched and colored? I have 6 out of 12. 6/12. So how can we, because we don't want to have to draw this every time that we want to figure out a multiplication. So what's the algorithm? How can we figure this out? So with 6/12, what we're doing is we're saying, first of all, the total number of rectangles, how many do I have? There's 12 of them. How can you quickly figure that out? Well, it's 3 times 4, which is 12. Here's my 3 and my 4 in my equation. 3 times 4 is 12. Whoops. 3 times 4 is 12. The total number of colored crosshatched rectangles is 6. Again, it's 2 times 3, which is 6. That's why when we multiply fractions, we go across, because of this area model. All right, let's go back to our fraction chart here. This as kind of as a summary. We want the children to use this fraction chart. Allow the child to explore the whole picture like we did, and the relationships within the whole using the linear perspective, and then other ways to work with it and allow the child to develop their algorithm and the way to do it so that they understand it. And it's not just a bunch of rules to memorize. In the Right Start Mathematics program, we are level A through G. Fractions is taught in all A through F, and then they're used in level G. There's most focus in levels D and F in the Right Start Math program. There is a carve-out available. So if you're committed to another program or you're using another program and you need to use that, you can get these ideas from Right Start with our Right Start Fractions book, where you learn fractions in 42.5 days. Now, in this Right Start Fractions book, you're going to have the lesson, and then the children play card games, as shown here, card games to practice what they've learned. Now, we didn't talk about any card games here. That's actually talked about quite extensively in part 1 to give you some ideas as to what kind of games we have. But in this book, almost every day, well, actually every day, the children are playing card games. There is a few worksheets, but not many. Most of the time, they're playing it with card games. The kit, we have a kit that comes with lessons, worksheets, the fraction chart, and the card decks used to play the game. The Right Start Math program has been given numerous awards. And if you want more information on that, you can check our website out or you can let us know. In conclusion, math needs to be taught so 95% is understood and only 5% memorized. And Dr. Cotter says our goal as the teachers of mathematics is to help our children transform, expand, and refine these beginning ideas into deeper mathematical thinking. Well, thank you everybody for participating in our part 2 of the Right Start Fractions, taking the fear out of fractions. There is also going to be a part 3 coming, and that is going to be on dividing fractions. Thank you and have a wonderful day.